apportionment problem. First of all, identify the standard divisor. And once you have the standard divisor, then we'll do the upper quota or the standard quota. And then based on the standard quota, you can then figure out what the upper and lower quotas are. You have to figure out the total of all the passengers. And you have 300 buses. Well, one way that you could divide those 300 is just to say, well, I have 1, 2, 3, 4, 5 routes. So if I divide the 300 buses by 5, that's going to be 60. Why not just do 60 buses for each of the 5 routes? It's a nice equal way to do things, right? Oh, except Route E has so many more passengers. So to accommodate all these passengers, we probably want to give them more than just 60 buses. These two are so close that, you know, we're going to give Route E more buses. We're probably going to give fewer than 60 to C and D, but they probably should be fairly close. And then the Route A over here that has fewest passengers, so maybe it should get fewest number of buses. So the 60, 60, 60, 60, 60 allocation, apportionment, probably wouldn't serve this city very well. More buses should be devoted to this route over here. Otherwise, people are just going to be standing at the bus stop. The bus will come by, it'll be full. And people won't be able to get on the bus. However, if you had more buses, then the buses on the route would not be as populated and you could get a ride. You probably want to keep some accuracy there, so maybe 3 places of accuracy. A lot of times the standard divisor will be a whole number. It's not in this case. Standard divisor, 3 decimal places, and the standard quota is 3 decimal places as well. And so the standard divisor actually has a meaning here. It means, because the top number is the number of passengers, 11,060. The bottom number is the number of buses. So if you divide those two numbers, you get this number, and then the unit passengers per bus. So once you identify that number, then all these other parts just say, okay, give the standard quota, give the upper and lower quotas. So part B is to complete the standard quotas. Part C asks you to identify the upper and lower quotas. Part D says use Hamilton's method, which is not to be confused with the modified divisor or the actual standard divisor. E is Jefferson's, F is Adams, and G is Webster's. Now all these other ones are going to be, I mean, you'll start off with decimal numbers, but eventually you're going to be rounding them off to the nearest whole number. So here's your 11060. Standard quotas will add to 300. The lower quotas and the upper quotas, this is going to be less than 300. This is going to be greater than 300. But all these other ones are going to be 300 when you're done. Because you have to assign, allocate, apportion buses to routes. So in the end, you just want to say you're going to take your fleet of 300 buses and you're going to put them out on a okay, so if you come up to 299 with Hamilton's method, then that means you have to go award another vote somewhere to the next highest standard quota, the next highest decimal piece of the standard quota. So since there are 5 different routes here, if your lower quota comes up to, let's say it's 297, then that means you have to award 3 additional buses based on the numbers you see here, 1 at a time. And you award them in the Hamilton's method, you award an additional bus to the lower quota by looking at the decimal piece of the standard quota. So if this was 297 and you had to give 3 additional buses, you're going to pick the decimal pieces here, the 3 highest decimal pieces, and ignore the other 2. Look for violations of the quota rule. Sometimes that might signal an error. Other times it's just the way the numbers come out. Remember what we're going to do to make our life easier. We're going to put all these numbers in a list. Okay, so L1, which would be these numbers, we're going to divide by our standard divisor. 36.867. Right, so these are the standard quotas. If you added them all together, you should get something close to 300, minus rounding error. If you don't have the lists, if you have a TI-83 or an 84, it will work. But if you don't have these, then you can use your calculator and it just takes longer, right? You've got to take 1087 and divide by 36.867. Get this number. And then you repeat. 1323 divided by 36.867 to get this number. And then go to the next one. Yeah, so because of rounding error, this is actually going to be 299.99. But that's only because of rounding error. All right, now we're going to get rid of the decimal pieces, and those become lower quotas. If you add 1 to the lower quota, you get the upper quota. Another way you can think about it, round down to get the lower quota, round up to get the upper quota. Those 2 numbers of rounding down and rounding up will always be 1 whole number away. And then plus 1, plus 1, plus 1, plus 1, and plus 1. Okay, 298. And we know that all of these 5 numbers are exactly 1 higher than all of these. So if you add 5 onto 298, you're going to get 303. I didn't give you these numbers purposefully, but for Jefferson's method, you want to choose a number smaller than. Okay, so D is equal to the 36.867. You want to choose a number that's smaller than this. It turns out it can't be too much smaller than this. Even if you go down to 36, it might be too small. So start small. Again, it really depends on the original numbers that you're given. But, like 36.7 might be a good starting point, or 36.5 or 36.3, but something pretty close to this number. If you go too far, if you say, oh, I'm just going to do 30, I know I got to choose a number less, look what's going to happen. So you take all the numbers in L1 and divide by 30 instead of 36. All of these numbers are much too high. 36, 44, 53. Compare that. Those are too significantly higher than the upper quota. So you're going to allocate many, many more buses if you divide by 30. So it's got to be much closer. All right, let me give you this one here, 36.6. See if that works. Yeah, so if you did 29.9, you're still in this problem because the first number here would be 36. In Jefferson's method, you round down, so 36. But 36 is way higher than what we want to allocate to that route. So a good check would be to select a number under this, 36.867. So, and the first number you want to see is one of these two numbers. It's going to be something other than these two numbers, then you want to get closer to the actual D. Okay, so the first thing is Hamilton's method, and you start with the lower quotas, 29, 35, 43, 44, 43, and 148. Now we know that those numbers add up to the 298. So we need to give one additional vote to one of these routes, one additional bus to one of these routes, and another bus to a different route. So we don't want to give both of the two buses to the same route, whatever it happens to be. All right, so we have to give away 2, so we focus in on the decimal pieces here. 0.15, 0.29, 0.18, 0.89, 0.48. Those are our 5 choices of decimal numbers. So which of those numbers is largest? 89. Since 89 is the highest decimal among all of these, then 89, or route B, gets awarded one of those 2 buses. So we're going to add 1 to, and so we're going to choose the upper quota here instead of the lower quota. All right, well, now that that one's done, we still need to give 1 more bus. And so what we're going to do is ignore that decimal and then focus on just the remaining 4. And of the remaining 4, which one has the highest decimal? 0.15, 0.29, 0.18. 0.48 is the highest of the remaining 4. So route A is going to get that last allocated bus. It's all based on the decimal piece. That's Hamilton. And since we've given 1 here and given 1 here, we've given 2 additional to add up to the 298. So therefore, these 3 numbers just stay the same and we have 300. If there's a easier way to add these numbers, and there is, and it's going to be in the list menu. I don't know if you can see that, but it's right above the stat key. It's in blue, and there's a sum function, S-U-M. Sum means you add up a bunch of things. So you can give the sum command and then give it the name of the list that you want to sum up, like list 2, and then it'll sum up all those numbers in list 2. So let's try it. First of all, go to your home screen, and then we're going to go into the list command, and it's over in the math menu here. You can see all of our lists there in the list menu, but we want to go over to math, and then it's option number 5. So when you hit option number 5, it says, all right, we're going to take the sum of something, and then you have to tell it the list that you want to add together. If it's L1, that would add all of these numbers. And what do those numbers add up to? 11060. If you take the sum of all the numbers in L2, you get 369. Way too high, right? When we only want to allocate 300 buses. I think those are the numbers that we used when I divided by 30. It's way too high. For Adam's method, you have to choose a number that's a little bit larger, and then we're going to round up. So maybe something like 37 would work, because 37 is larger than that. So let's start with, you know, if D equals 37, would that work out? So I'm going to follow up behind you and do Jefferson's method with this common divisor. So we select a number lower than the common divisor, and then we're going to round down. So I'm going to write the decimal version, and then we're going to round them down, see if it works out. So highlight the L2, and then take the numbers in L1 and divide by the 36.6. We get 29.699, 36.148, 43.497, 43.607, and 149.23. All right. Those are not actually the numbers that we want to go in there, but now we're going to choose a smaller number and then round down. So just lop off the decimal and then just keep the whole number piece. So keep those numbers. So 29, 36, 43, 43, and 149. And if I sum up all those numbers in L2, I get, oh, I didn't round them. If we take the numbers in L2 and round them down, all right, so let's see if we can find a math function on here to do that. But I mean, sometimes it's just easy enough just to write those up. And you can confirm this, but yeah, those four numbers do in fact add up to 300. There is a math function, a rounding function in here in the math menu. So if you go math and under number, you get all these rounding pieces. And this I part means the integer part. So if you do the integer part of all those numbers in L2, look what you get. 29, 36, 43, 43, 149. I part, integer part. First of all, sum. If you wanted to do sum of L2, if you wanted to add up all the numbers in L2, you would go to second and then stat. And those two together make up the list commands. Stat, right above stat is list. So second and then stat, right above stat gives you the list command. So here you are. Then you want to go over to the math menu. And then option number 5 is sum. So that goes to your home screen. And then you have to tell it what list you want to add together. So remember, all the lists are down here. Right above number 1 is L1, right above the number 2 is L2, and so on. They're in blue, so you have to hit the second key to get to them. So second, 2. And together that would give you L2. And then enter. All right. The other one, in the math menu, number I part. Another way to say this is you want to just truncate. Truncate the decimal part. I part. Okay, so there's a key on your keyboard called the math key. A bunch of math functions in it. There. And then there's several menus up here. Complex numbers, probability, math functions. Oops. Math functions would include all of these. but you want to do something to numbers. So you want to go over to the number menu. And then after you're there, you want to select option 3, IPart. And then you have to tell it, you know, the integer part of what. If I did the integer part of 12 point, this number, what's the integer part? 12. If I do the integer part of 0 point all of that, 0, and so on. But I can also do the integer part of an entire list. So that's what I'm going to do. I'm going to go back to the list though. And so if I clear out these guys and if I highlight L3, and then down here, I do these same commands, math, num, integer part, so that the integer part goes down here. Then I can say I want to take the integer part of all those numbers in L2 and take L2. There you go. And try my 37. And then I want to talk about where you go from there. Okay, and it really depends on how many votes you have down here. So let's try 37. And we're going to divide all the numbers in L1 by 37 right on the nose. Now with Adam's method, to round that, I'll just show you this once here just so you can see it. Oops. For Adam's method, you're going to choose a number that's a little bit larger and then round up. We're going to round up. Now to tell the calculator that you want to round up, the way you can do it is you can go to the math menu, over to number, and then do the integer part again, but you want to take all the numbers in L2 and add 1 to them. So this is how it would work. We want to round this number 29.398 up to 30. So we want this to be 30. We want the next one to be 36, the next one to be 44, the next one to be 44, and the last one to be 148. We want to round up. And this is how you would do it with this. So notice that if you add 1 to all these numbers here and then take the integer part, it would be the same thing as rounding up. So 29 point some change goes up to 30, 35 and change goes up to 36, 43 and change goes up to 44, and so on. If you add these numbers together, 10, 22, I'm at 302. All right, so when D was equal to 37.0, I got the total to be 302. Now the question is, where do I go from here? Now this is too high. Since this number is too high, I need to increase this number a little bit, because if I divide, because I'm going to take all these numbers over here and I'm going to divide by this divisor. If I divide by